Let's say I'd like to do a very simple calculation of the distance an object traveled, or of its displacement, over 5 seconds, time of 5 seconds, and it was traveling at a velocity of 10 meters per second, 10 times 5. Well, the distance it traveled, or its displacement, would be displacement equals 10 times 5. If my units were meters and seconds, that would be a distance or displacement of 50 meters. Well, the interesting thing to notice is that this can be seen geometrically and visually with a graph, because the two components that I'm interested in, velocity and time, are the components of my graph, velocity and time. So for instance, if I had plotted a uniform motion of 10 meters per second, it would look like this, because I was moving uniformly at 10 meters per second. If I said, how far will I have gone, or what would my displacement be after 5 seconds, well, I can get this unit, which is 10, multiply it by this unit, which is 5, and I can get 10 times 5 is 50 meters. You'll notice that 50 meters is the area of this graph, or of the shaded region. So it follows that the area under the velocity time curve, I call this a curve even if it's a straight line, is equal to the distance that an object has traveled. Let me find out what the distance it travels if it doesn't continuously stay at 10 meters per second, but if it accelerates to 10 meters per second over that time frame. So this is velocity, this is time. Remember, those are the two components I'm interested in multiplying by each other to get my displacement. Velocity, time, same setup, 10 meters per second over a period of 5 seconds. But let's consider an object that wasn't moving uniformly at 10 meters per second, but accelerated from 0 to 10 meters per second. So that this was its curve, showing an increase in velocity or an acceleration. Well, in this particular case, you can think to yourself, the area under the curve is going to be less than that under the uniform motion curve. In fact, it'll be this area. This is the area of a triangle that is half of a rectangle which has an area of 10 times 5, just like this one, but the new area is like this. It is 1/2 10 times 5 equals 25. So, in the case of accelerated motion, you're frequently dealing with a triangle, and you'll have to calculate the distance by taking 1/2 the area of the rectangle, which would have given you the distance had it been uniform motion.